Hi, everyone. Welcome to our next webinar. I'm James.
I'm Diego.
Today, we're talking about alien planets. As you can see behind me here, we have an alien planet.
We come in peace.
Okay, I've checked the atmosphere. The atmosphere is breathable. It's the right density. It's the right thickness. It's the right composition of chemicals and gases that we can breathe it. This is really good.
Time to set up shop.
Yeah.
What do we build first?
Okay, first, a burger stand. First, we need burgers. It's the first thing you need on an alien planet. Okay, everyone. We are talking about the search for alien planets today. And what I pulled and put up behind me here, this is what an artist thought that an alien planet might look like. And you see a red star in the sky behind him, which, as we learned about, was it yesterday? I don't know. I think yesterday when I was talking about stars, we were talking about stars. If it's red, then it's got a cooler surface. So it's a cooler star than our own sun, which means the planet can be a lot closer and not get fried. And you can see a couple other, maybe those are other planets or moons in the sky. I just thought it was really cool.
Yeah, it's awesome.
Yep.
I think my place would go here. There's like there's a lot of places to set up a house.
Yeah.
Okay. The water.
Good. And I see that many of you are talking about that you're building your own helmets at home.
Yeah!
And we had a few people send in pictures and videos of their helmets. Thank you, everyone.
That's awesome.
I love it. Good. Hey, Diego.
Yeah.
Let's talk about alien planets.
Alien planets.
The search for.
I think you have tons of slides.
I think so.
Through this. This is an awesome subject.
Yeah.
Love it.
So what I called today's talk was the search for alien planets, because I knew that that would sound interesting. What I said was alien, and what alien means was coming from a planet other than our own, or coming from a star other than our own. What I meant to say, and what I chose not to say in the title, because I didn't want to say a word that people didn't understand, was exoplanet, a planet that orbits a star other than our own. Exo meaning external, from the outside, and planet being a big ball of rock or gas orbiting a star. So a planet from outside our own solar system.
Exoplanets.
So with that being said, welcome to today's actual talk, the search for exoplanets.
Yeah.
Okay.
Very cool.
Now, when we're going to try to learn something new, it's useful to compare it to something that we already know about. If I am going to learn Spanish from Diego, I'm probably going to be comparing it to English, which I already know and am familiar with.
Okay.
So before we go looking for other star systems, let's make sure that we understand our own, or get an idea of our own, so that we can compare other systems to our system. So here is our solar system. This is nice. This is comfortable. This is what we are familiar with. You have 4 smallish rocky planets on the inside near the sun. And then you have the big gas planets farther away where it's a bit colder, right?
And it's important to say that these distances aren't to scale.
This is not to scale.
But it looks like the note that you have there that this is the scale of the planets.
Yeah.
The sizes to each other, right?
Yeah. Oh, someone asked, what planet am I on? That's just that planet that we have in the background there. That's just a made up planet that an artist made. Like, I don't know. Seems like a cool alien planet. And I agreed with him, so I put it behind us. Okay, people are saying, where's Pluto? Where's Pluto? All right, Pluto's further that way. I didn't show Pluto on here because it's not fully classified as a planet. And we could fight about that all day, but we're not going to. Someone asked, what did we name this planet behind us? Let's name it Diego. It's the planet Diego.
Planet Diego.
Good, yeah.
Welcome. I run things over here.
Because that planet seems really cool, and Diego's really cool. So, okay, good. So 4 rocky planets close to the star where it's hotter, and then 4 gas giants, bigger gas planets farther away from the sun where it's a bit cooler. And when scientists first started looking for other star systems and other planets, they thought that they could probably find some systems that looked like ours. So they were a little bit surprised when they started finding what they actually found.
Yeah, a lot of people believe there was life on Mars.
Right.
They were looking up and they would see the canals.
Yep.
There's little channels on Mars and they would change.
Yeah, so people thought that there were like aliens on Mars building stuff. No, that was just, the changing of seasons over there. So here is a top-down view of our solar system with the sun in the middle, Mercury, Venus, Earth, Mars, those orbits. And then zooming out a bit more, that tiny inner circle right there, those are those 4 inner planets. And then moving out, you have the orbits of Jupiter, Saturn, Uranus, and Neptune. Okay, so we have a picture of our own solar system. So now we can go looking for other planets, other systems out there. How would you, our loyal dear viewers, look for planets other than those in our solar system? I'm going to give a second for you guys to put your answers in here as I answer a question. A couple of questions. Lorna, you're late. What's going on? That's totally okay. Welcome. We were almost late today. That's totally fine. We're talking about the search for alien planets, the search for planets outside of our own solar system. Logan asked, does Mars have any moons? Yep. 2. Phobos and Deimos, I think they're called. And they're both very small. Okay, good. So someone says telescopes. Yeah. So use telescopes to look out there. Someone said to make a spaceship that's really fast. Alette, that's a good answer. That's tricky. It's difficult and it's expensive. And as soon as we find the right technology, I'm sure that we're going to be sending spaceships out to explore other star systems.
And space travel is getting cheaper right now as we speak with every year that passes.
Yeah. So yes, telescopes. Now, a small telescope like this that you can use in your own backyard, that's good, but it's not good enough to see planets in other solar systems. So what if we use an even bigger telescope like this guy here? You've probably seen pictures of observatories, these big domed buildings, and they open up. And you can see the telescope inside. I know, I come with sound effects.
I almost started dancing with my robot.
So you can see there's a pretty big telescope in there. Well, even those weren't really good enough, or even they were difficult. Here's some other telescopes, right? So this is called the Very Large Telescope, the VLT. That's its official name. Someone's like, that's a telescope. That's very large. What shall we call it, Diego?
Let me think. Large. It's
very large.
It's very large. How about the Very Large Telescope?
That's it. Bingo. All right. Well, then they were like, well, let's see. We want to build an even bigger telescope. We want to build an extremely large telescope. Diego, that telescope's extremely large. What should we call it?
How about the Extremely Large Telescope?
Bingo, you got it. So this is not built yet, but they're building it right now, and it's called the Extremely Large Telescope.
Oh, wow. Where is this going to be?
Earth.
I
forget where on Earth. Okay. I looked it up. I had that answer. I forgot.
Okay, awesome.
But as you can see, it's almost as tall as the Statue of Liberty. It's extremely large. And when that is built, they will be able to see a lot more in the night sky.
Gosh.
So you're looking out, you're looking for planets. There's still one big problem here. Stars are really bright. Diego, look at that light bulb.
Whoa.
Tell me what's immediately next to the light bulb. You can't, because it's so bright, right?
Right. It's too bright.
Yeah. If I told you to look for a speck of dust immediately next to a light bulb.
I got a great demo here. If this is our sun, and I'm asking you to observe something that's like right here, and it's just doing this all the time.
I can't see it. I can't see it. It's too bright.
Yeah.
Sasha says, You're right, Sasha. So one way to look for planets is to cover up the star so it's not shining in your eyes. These guys have the right idea. This guy has an even better idea. He's got sunglasses, and he's putting his hand up to cover that light. Okay, so go ahead and shine that light again there, Diego.
Okay.
All right, so now
Now,
you can see what's next to it.
and
Like
if this was a planet.
right. So go and hold it right there. How many fingers am I holding up? You can't see. How about now? You can see 3. So that's a really simple way of explaining it, but that's also exactly what these guys are doing in a really advanced science-y way. So this is a picture of an eclipse. This was the eclipse that happened in Oregon just a few years ago. And normally you can't see that glow around our sun, but because the moon was covering the sun, now you can see what's around it better.
And I can't tell if my screen's dusty or is there any suns? Is there any stars that are visible around now that it's?
I can't really tell. There might be dust on my own screen too. But the point is you cover up the brightest thing and then you can see some other less bright things
And I
right around
remember
it.
during the eclipse, you could see some stars in the middle of the day.
Yeah, I remember that. That was so cool. That was so cool. I can't wait for the next eclipse. Texas, April of 2024. That's the next big eclipse
Cool.
in North America. Okay, so there's 5 ways to find a planet, to 5 major methods of finding a planet. We're going to talk about each one just a little bit, and then we're going to concentrate on the last one. So method number 1 is called direct imaging. You get the image, the picture of it directly. And that's, you block the star and you can see the planet. Number 2 is star wobble. What do I mean by that? So let's say, I mean, we've all done the thing where like we hold hands with someone else and we spin around in a circle and you're both spinning, right? Here's a dad spinning his daughter around. I used to do this with my daughter when she was younger. And what's happening here is, you know, one person, the lighter person is spinning in a big circle, but the person in the middle, the dad, he's also spinning in a circle, but it's much smaller. It's a much, much smaller circle. Well, if you were looking at the beach and you had the sun in your eyes and you just saw a dad spinning in a circle like that, you could kind of figure out for yourself, he must be holding on to a small child and spinning them in a circle. Like that's the only thing that could explain
We're dancing.
his wobble like this, right? So that's what they do with stars is they look at the wobble of the star as it wobbles back and forth.
That is a great
and they're like, okay, it shouldn't, the only reason physically that it should be wobbling like that is if there's a planet that's orbiting it. So that's one way. Another way is to compare the star to other stars. This is very, very similar to the wobble. And, you know, if there's a bunch of stars in the sky and you see one star wobbling a certain way compared to other stars, you can get some data from that. It's a bit more complicated than that, but we're trying to keep it very simple until we get to the last one. Mm-hmm. Okay. Number 4 is a really complicated one. I'm not even going to get into it. Just there's a 4th way. It's really complicated.
Can you even try? I'm like in mystery right now.
No.
Is it math? Is it math?
Oh, this is all math. I tried for 40 minutes to try to figure out a really, really, really simple way of explaining this. And we could do 45 minutes just on this next thing. But again, I don't want to give you too many words that you don't understand. So don't worry about it.
We'll talk later.
There's people that go to school for 50 years to figure out how to do this. They're really smart. Okay, good. Number 5, and this is my favorite. And this is the planet passes directly in front of the star.
This is a surprise demo. You want to run this?
All right. Oh, Lorna says that the picture looking down on the sun, that picture was taken the day after she was born. That's amazing. That's a historic photo. Lorna was 1 day old.
Screenshot it.
All right. So,
how do you want?
Right. So let's say that we, the observers here on Earth, are looking at this star. And we are looking at this star and we notice that the star gets dim, right? There's a certain amount of starlight, and then all of a sudden the light is less bright and then it's brighter again. And we can figure out from that that something passed in front of that. It's like if you're looking at a light and someone walks in front of the light blinks at you for a moment. And you can figure out, oh, something just passed in front of that light.
I've heard scientists try to compare it to trying to see the mosquitoes on a street light.
Yeah.
In the middle of the night.
Yeah. So that is called transit. Transit means to pass through or across a place. I drove across America one time. I transited America. So here is an actual picture. Here is Venus transiting the sun. And you can see how small Venus is compared to the sun. But if you were watching the sun with a very strong instrument and keeping very close measurement of exactly how much light you were getting from the sun, you know, you would see the light is this much, and then Venus crosses in front of it and the light goes doop, and then Venus leaves and the amount of light that you're getting goes back up. Here's Mercury transiting our sun, and it's very small there, but again, if you have very sensitive scientific instruments looking at the sun, you can tell just because of the dip and how much light you're getting.
And I had an opportunity to see the Venus transit, and it, like, we were using a sun telescope, and you could see the image right on the ground. This was outside Adams State College in Colorado.
Oh, cool.
And you could see the little dot go across. It was the coolest thing. And you're just seeing it in real time. There's Venus. Everybody's in the courtyard celebrating. That was really cool.
That's so cool. So we can see stuff in our own system through this transit method. And we can see stuff in other systems through the transit method as well. Okay, good. So Mina says, like in the airport, there's a place called transit. Right. You're passing through the airport on the way to something else. Someone asked, what's that black spot on the side? And Shanna says, it's a sunspot. Right. That's a sunspot right there. Every star, and especially ours, because we're able to see it so closely, it'll have points where little spots will show up on its surface where it's suddenly not as hot right there. It's like something popped. It was like a bubble that popped and then it fills back in. Sunspots are really funny. Yeah. Okay, so huge telescopes on Earth are a good way to look at space. And it's even better to look with a telescope that is in space itself, because down here we've got clouds and birds and an atmosphere and stuff that can get in the way. So humans were like, let's launch telescopes into space. And other humans were like, yep. So Hubble Space Telescope, this is probably the most famous space telescope. It launched in 1990, and it has provided us with some of the most incredible images of space ever taken. And
just amazing science that they've gotten out of
amazing
Hubble.
Science. Yes, a couple of our very astute viewers have said that there's a new telescope in space. Yes, this was one of the first. There's been many others, and I have a bit of a kind of a timeline of those coming up later on. So Hubble launched in 1990. In January of 1992, the first two exoplanets, alien planets, planets outside of our own solar system, were officially discovered. And that was a very cool, exciting, important moment in space science history. We knew that alien planets, that exoplanets had to exist. Mathematically, they had to. It was impossible for them not to. Either that or we were completely wrong in way more things than we thought.
Yeah.
So the fact that they finally found two exoplanets for real, for sure, was very exciting, because it's like, you know that something is there. You know that your favorite TV show is on right now. And you know that if you just can figure out how to turn on your television, you can watch that episode of, that TV show. And then you finally figure out how to turn on your TV, and there it is. You knew it was there, and there it is, and it's super exciting. In 1999, they caught the first exoplanet transiting its star.
Cool.
This is a picture of Venus transiting our own star. But that method they were talking, where the planet passes in front of the star, 1999, they observed that for the very first time. Since 1992, where you see the first little blip right there, here's the number of exoplanets that have been discovered every year since then. So
2016, that was a
2014 and 2016 were huge years. Look, 2016, almost 1,500 exoplanets discovered in just that 1 year.
Wow.
And the colors on this graph show what method was used to discover that planet. And you see very small bars for these other ways that we talked about. Star wobble, with the dad spinning his daughter around, and you can't see the daughter, but you know the dad, you know from watching the dad that the daughter must be there, and about how much she weighs and how big she is and stuff like that. So that's that green bar right there, star wobble. And that purple band right there, that is through the transit method that they were able to confirm certain planets. So you can see we're discovering a lot of these. There's over 4,100 known confirmed exoplanets that we know of right now.
Wow.
All right.
Very cool.
Oh, someone pointed out that in our background, there's a planet transiting this star. Yes. Let's see. Who is that? Who is that? I need to pull up your
Give him
name.
a shout out.
Amelia. Thank you.
Amelia.
Yes, exactly. So we would be able to see, hey, there's a planet there because our star got dimmer.
Yeah.
Okay. We have to talk about this. And here's a big word, but don't worry about it. We're going to find out what this word means. It means, the word is spectroscopy. And it sounds like you're casting a spell in Harry Potter. Spectroscopy!
Here it is.
Turns you into really cool colors. So spectroscopy is the science of looking at the light from other planets to see what they have in their atmosphere.
Yeah. And
Okay.
I would add to that spectroscopy could be finding out what something's made out of with just the with the light.
Just the light.
Figuring out what things are with the light.
So you like go ahead.
This is a spectroscope. So basically it has some lenses inside, and the light gets bounced around and it'll turn it into like a rainbow kind of thing. So you'll have different colors.
Yeah.
And so when you're looking through at different suns, you can estimate or kind of do some guesswork and logic work on what is in the great beyond based on that.
Yes. So
Because it gives you colors. I'm gonna try.
here we go.
I'm gonna try one thing. Are we getting any kind
Can you
of?
see a rainbow from that? A little bit.
A
A little bit. You guys can
diffraction
kind
rating.
at the right angle. We can kind of see a rainbow
Ish.
ish. Okay. Yeah. There we go. So here's what happens. So let's take this planet right behind us. Let's see. There we go. As that planet is passing in front of that star, here's the thing. We know exactly what the light from this star looks like.
Because we have spectroscopes.
Right? So we can see some of that light passing by this planet is going to go through its atmosphere, if it has an atmosphere. And that atmosphere is going to change that light in certain ways. So we can see the light from that star, and we know it should look exactly like this. And we compare it to the light that we see coming just past that planet that passed in front of it. And the light from this planet is just a little bit different from the light from the star. And that can tell us a whole ton of stuff. So certain things are going to absorb certain colors.
Here's one color. There's a filter on us.
Yeah, there's a filter on us. And now we're yellow. And now we're blue. That's my favorite color. Here we go. I'm blue.
Green. How's green do? Oh,
we start disappearing into the green screen. All right.
Blue. Yeah,
All right. A bunch of people are saying, what? Yeah. So that's okay. I knew that this was a big word. I knew that this one was a little bit complicated, but we could not talk about the search for alien planets without talking about spectroscopy just for a tiny bit. Okay. So we can tell that so like, let's say here's a star, the light comes from that star, and it passes through the atmosphere of a planet as the planet passes in front of the star. And then we get to see the rainbow from that planet. And if we're looking with the right science instrument, the rainbow will look like this: red with a little bit missing, orange, yellow with a little bit missing right here and right here, green, blue with a little bit missing, violet with a little bit missing. We know from exactly what little lines are missing what is in the atmosphere.
And the triangle that's in there is just this piece of clear glass triangle.
Yeah.
And what it does is it fans the light out.
Yep.
It helps you tell more what's inside the light.
Exactly.
So if you ever have one of these, you just hold it up to the light and you'll see rainbow colors come out. You've seen this when there's oil on the ground, or
if there's a rainbow in the sky,
yeah.
Right? It's the rain in the air acting as a prism, breaking up the light from our sun. So scientists can look at those rainbows from the other planets and see what's missing and tell exactly what is in the atmosphere. They know that hydrogen, the lightest gas, the lightest element in the entire universe, if light passes by hydrogen, through hydrogen, the hydrogen will eat that color of light right there. Not that color, not that color, just that one tiny line of light. It's going to eat that color.
It's absorbed.
Yep.
Another word for eating
Absorb.
it. Absorb.
Right. So you see absorption lines. That means this is what did not make it through. This is what was absorbed. This is part of the light that was eaten when it went by. They know that if there's this and this line missing, that means that there's sodium. Sodium is part of what makes up your table salt. They know that if there's these two lines missing, that means there's calcium in the atmosphere. Calcium is part of what makes up your bones. So they can tell from this fancy rainbow that they get from this light exactly what is in the atmosphere. That's so cool to me. So spectroscopy is studying rainbows of other planets. How's that?
That's cool.
Study of alien rainbows.
I'm doing it right now.
Right? Okay, good. So I'm sorry if that was a big word. I just had to share my excitement on that. All right, now let's talk about some numbers really quick here. Isa says, I need to hurry. Yes, I know. So we're officially scheduled to end at 3:15 today. I think we're even going to end at 3:15 today. If you were with me last week, I went 20 minutes extra. If we have to do that this time, we will. And if you need to go, that's totally okay. In a few days, this webinar, the entire recording, is going to be on our YouTube channel, and you can watch everything. So if you have to miss something at the end, if you have to go and eat dinner, totally fine. Catch us on YouTube in a few days. If there's something we said in here that you didn't quite get and you want to watch it again, YouTube.
Yeah.
Okay, so I'm getting some questions. What kind of planets have we found? Have they found anything like Earth?
Great
Good.
questions.
Let's talk about that.
Keep it rolling.
You guys are good scientists. You asked the right questions. So what it looks like right now is that every planet in our galaxy has at least one planet orbiting it. They haven't found any science that shows that it's not that way yet. So, and they can make some pretty good guesses that that's probably the case. About 1 in 5 of those stars have planets at the right distance from their sun to have liquid water. And it's estimated that there's about 1 trillion planets in our galaxy. So 1 out of 5 planets of 1 trillion planets, that's a lot of planets. That's billions of planets that they think are the right distance from their stars to have liquid running water.
Wow. The odds for alien life.
Right. So let's look at some of these exoplanets that we've found. This is, I had to show it first because it's my favorite exoplanet system. It's my favorite group of exoplanets. This is called the TRAPPIST-1 system. It's called TRAPPIST because TRAPPIST is the name of the telescope that found it, and 1 because it's the first system that TRAPPIST found. So if TRAPPIST found another system, they would call that TRAPPIST-2. And another one, they would call it TRAPPIST-3, right?
These guys are really creative.
Yeah, but also TRAPPIST-1. That sounds like something from sci-fi. That sounds like something from a movie.
That's cool.
Sir, we've detected Enemy forces in the TRAPPIST-1 system. Launch fighters.
Planet D.
Yeah. Planet D. Okay, so here on the bottom here, you have an overlay of our own solar system. Remember when I said it was important to understand our own solar system so that we could compare? That's exactly what we're doing. So all of these planets in the TRAPPIST-1 system, here's the orbit of Mars, here's the orbit of Earth and Venus and Mercury. If you go in for Mercury really close to our star, the entire TRAPPIST-1 system fits in that little bit right there.
Whoa.
It's a really tiny star system compared to our own. But let's zoom in a little bit, right? Let's look at that 25 times closer than we're looking at it, our own solar system.
Wow.
This is what that looks like. Now, that's not...
Our solar system has a lot of space.
It's got a lot of space. So this isn't the actual size of the planets, but these planets that they're showing here are about the same, are the same scale as the planets that you see in our solar system right here. So planet E right there, it's about the same size of Earth. Planet D is a little bit smaller than Earth. B and C are a bit bigger than Earth. That's really cool. They think that B and C are more gas planet than rocky planet.
I think I'd want to live on planet D so I could finally dunk a basketball.
Hey, yeah, I could, yeah. Maybe even I could dunk. I don't know. Another thing that they show on top here, here's Jupiter and the orbit of Jupiter's moons and relative to the TRAPPIST-1 system. So you could think of the TRAPPIST-1 system as kind of like Jupiter and its moons, just a little bit bigger. But it's really small compared to our own solar system. Here is why TRAPPIST-1 is so exciting. If you looked at where could liquid water exist on a planet, in our own solar system, Mercury is way too close to the sun. It's too hot, so it's in that red zone. Venus, Earth, and Mars are all kind of in that green zone there. That's called the habitable zone. Habitable means you can live in it. You can have a habitat.
They'll also call it the
Goldilocks zone.
Ah.
We're probably all familiar with the fairy tale of Goldilocks and the Three Bears.
Tell me the story.
Well, it all talks about the, this girl's hungry. She wants to eat, right? Anyway, so she eats 3 bowls of porridge. The first bowl of porridge is too hot. The second bowl of porridge is too cold. The third bowl of porridge is just right. And she eats the whole thing. So in here, it's too hot. Mercury's too hot for us. Out here, it's too cold. And right in the middle, that's the right temperature. Earth is in the perfect spot in our solar system's habitable zone, our Goldilocks zone. Venus is just a bit too close, just a tiny bit too close, and it's too hot. Mars is on the very edge, and it's too cold for us. Did you know that it gets up to like 70 degrees Fahrenheit on Mars in the middle of summer?
Yeah.
In the middle of summer,
not bad.
It's
not
about
bad.
the temperature that it is today for us. That's the hottest day ever on Mars. So
the equator.
Yeah. So let's take a look at the TRAPPIST-1 system. Look at this. So B, C, and D are all a little bit too hot for us. E, F, and G, especially F, man, it's right in the habitable zone. It's right in the Goldilocks zone. And then H is too far away. It's too cold. It's going to be very icy. But E, F, and G could all have liquid water on it. That's really exciting for us. 40
light years away, if we send a rocket now, it'll get there with our current technology. It'll get there when?
Long time. long time.
That's a long trip.
Yep. Let's see. Mina says that one of those planets looks like Earth. Yeah.
That's right.
Now, we don't know that this is exactly what those planets look like. These are guesses of what it could look like. But yeah, I think one of them could look like Earth.
Yeah. Through spectroscopy, through some of these mathematical models, they have a high probability of being Earth-like.
Yep. Okay, Ranbir asked, what type of star is in the TRAPPIST-1 system? I hope you were watching yesterday because we learned about a bunch of different types of stars. That is a red dwarf star. It is much smaller than our own sun. It's much cooler than our own sun. And that star is going to live for trillions of years, probably. Our own sun will live for another 4 billion years. long after our sun is gone, the TRAPPIST-1 system will still be there. It's just going on its way. Okay, so let's take a look at some more systems. Now that we've looked at the Goldilocks zone, the habitable zone, we're going to look at some more. Again, here is our solar system on the bottom for some comparison. Mercury, and then here's Venus, Earth, Mars, and there's our habitable zone right there. Here's the Kepler-47 system. Kepler, named after the space telescope that found it, the Kepler Space Telescope, and 47 because it's the 47th system, star system, that Kepler found. And look at this, right in really close, even way closer than Mercury's orbit to our own, is this planet here. This planet is way bigger than Earth. And then in the habitable zone, there's this gas giant. Wait, I thought that you had to have small rocky planets close to the star and big gas planets farther away from the star.
Whoa.
This doesn't follow that rule.
Yeah. Changing our understanding
Wait,
all the time.
TRAPPIST-1, hang on a second. TRAPPIST-1 has bigger planets on the inside. It's not supposed to do that.
Strange universe.
So we made some incorrect assumptions about how a solar system should form, or should be formed, should be put together. We were wrong. That's so exciting.
Yeah, it's awesome to be able to find out what we don't know.
Yeah.
And that stuff that we assumed was correct is not correct.
Yeah.
It's great time for science.
Good stuff. So this planet, Kepler-47c, a really beautiful name. We could not live on that planet because it's too big. There's no solid surface and the gravity's too high. But let's say it had a nice moon around that planet. We could live on that moon. It's in the right zone to be warm enough and not too cold. Here's Kepler-62. Again, comparing to our own solar system down below.
Kepler's ranking it.
Man, Kepler's
this is
awesome.
The 62nd system.
Yeah.
Wow.
You remember that year that we saw, 2016, that had like 1,500 planets that it found?
Yeah.
Most of those planets were found by Kepler.
Wow.
Yeah.
I did not realize it.
So
Go Kepler.
Go Kepler. Team Kepler.
Yeah.
So we have two planets here that are in the habitable zone. One on the very inner side of that habitable zone. And you can see, compare it to the size of Earth here, those two are just a bit bigger than Earth. So you would probably weigh maybe 20, 30% more on that planet than you do here. So you could not dunk.
I wouldn't want to go there.
You definitely have to work out. Kepler-90. This isn't showing habitable zone, but it's showing the size of planets that we know are orbiting it. And look at this. You've got some smaller ones on the inside, but they're all bigger than Earth. And the further out you go, you get the bigger and bigger gas giants. That's more what we expected to find.
Mm-hmm.
That's what I expected. So there are other solar systems out there very similar to ours.
Kepler's a conformist. I mean,
Yeah.
follows the pattern.
Yeah, like Kepler-90, right?
Kepler-90.
They know that Kepler-90I is in the habitable zone. And it's kind of Earth-ish in size. So maybe that could be a good system for us. Here's Kepler-186 and Kepler-452. Here's our own solar system on the bottom. And here's Kepler-452. And you can see it's got about the same habitable zone that we do.
Wow.
There's Kepler-452b. That's right about at the same orbit as Earth. Same distance.
Do we have any idea how many light years this is away?
I might have that on another slide. Okay. And look, Kepler-186 is back to another red dwarf. It's a much smaller one, much smaller habitable zone. Okay, I'm just throwing names and numbers and words at you guys. I hope that this is interesting. We got about 5-6 minutes left. I'm going to try to cover all this. If we go a few minutes over, then I apologize. So this slide is a few years old. This said that there's 3,700 known exoplanets. We're up to like 4,100 now, 4,200 known confirmed exoplanets. And as for the size of those exoplanets, about 5 of those planets they know are what's called mini-Terran. It's about the size of Mercury. Terra is another name for Earth. So if we're saying that a planet is Terran or like Terra, then it's like Earth. So mini-Terran, mini-Earth, 5 of those. There's 72 sub-Terrans, less than Earth, smaller than Earth. So about the size of Mars, 72 of those. 701 exoplanets that are about the same size as Earth. 682 planets that are bigger than Earth, still rocky, but bigger, so we'd be much heavier on them. About 799 that are about the size of Neptune, and more than 1,200 that are the size of Jupiter or larger.
Wow. So the stats are showing us that more planets so far are Jupiter size.
Or that it's easier to find the bigger planets.
Good,
right?
Good point.
Notice the bigger it gets, the higher the number.
True.
It's easier to see Jupiter than it is to see
I was jumping
Mercury.
to conclusions.
That's okay, right?
Yeah.
That's okay. Maybe there are more Jupiters than Earths.
Yeah. That's where we're finding more.
But we sure know that it's easier to spot them because they're bigger, right?
Yeah.
So here's a slide with some potentially habitable planets. These are planets that they think might be good for us. Might be the right temperature, maybe have liquid water, about the same gravity as us. This one right here, this is the most interesting to me. This is Proxima Centauri B. And it's about 4.2 light years away. That's right next door to us. That's the closest planet to our own solar system. In any direction is 4.2 light years away. Proxima Centauri B. You can compare its size right here to the size of Earth over here. It's just a little bit bigger than Earth. So about the same gravity, maybe a little bit heavier. And it's in the habitable zone around its planet.
Wow.
Tau Ceti E, 12 light years away. It looks like a big icy planet maybe, but maybe we could get some liquid water there. These are just some.
Earlier I wanted to choke because I looked at the Kepler 452. It was 1,400 light years away.
Yeah.
It got me.
It's not very close to us, but that's okay.
Yeah.
Anyway, here's one. Tiergarten star B, or T Gardens. About 12 light years away, about the same size as Earth. There's a lot of possible exploration, a lot to learn about these.
Wow.
Okay. Do these planets have water? Do these planets have an atmosphere? There's some missions that are launching soon to answer those exact questions. We know that about some of them. We don't know for sure about all of them. Okay.
What is this?
I hope this comes through clearly and that it's not too choppy. This is on where I'm hovering my mouse right here. This is our own solar system. You can see here's the orbit of Mercury on the inside, and then Venus, and there's Earth's orbit right there. This is illustration showing a bunch of different exoplanet systems that we found compared to our own. And look at how fast most of them are moving. Zoom, 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 zoom. Some of these planets orbit their suns every 7 hours or less.
7 hours.
Like, look at this. This is like a Jupiter-sized planet right here. It orbits its planet every 7 hours.
I want to ask viewers how long it takes us to orbit our planet.
Oh, yes. Does anyone know how long it takes Earth to orbit our sun?
I mean, yeah, our Earth.
Yes. Okay. April is very conscious of the time. April says we have 1 minute left. You're absolutely correct. I'm going to go a little bit long today. There's no webinar after us scheduled, so there's no rush on that. And we're going to go a little bit longer. Again, if you have to go, totally okay. Thank you so much for joining us. I'm talking so much, I'm coughing. And if you miss anything, we are going to be on YouTube in a few days. All right. 375 days. That is correct, Oliver. Very good. And a bunch of other people said that. Yep.
365.
What'd I say?
375.
Oh, I'm sorry. 365.
365.
I need to take a sip of water. Liquid water, because we're in the Goldilocks zone around us.
Yes. It's nice being in the Goldilocks zone. We have sunshine and water and trees grow and grass.
Yep. Good. And the color of these planets that you see orbiting their stars here shows temperature. The red ones are like lava. The surface is lava. They're super hot. The white ones are about the temperature of Venus, still too hot for us. The blue ones, that's what we want. Blue means the same surface temperature as Earth, which is really good. Okay, I just thought that was really cool.
Yeah, that's
Look,
a really
now,
good graphic.
what strikes you about this? What strikes you about all these solar systems compared to our own?
They are fast and they're
fast and small.
Yeah, fast and compact.
Right. Now, why might it be that most systems that we see are fast and small? Now, keep in mind, in order to in order to actually see these planets had, let's see, what slide is next? I'm going to cheat. I'm going to look here. Okay, good. So in order to see these planets, the planet has to pass directly in front of its star compared to how we're looking at it. And just once isn't enough. We need to see it pass at least 3 or 4 times. And every time it passes, we can get a little bit more data. So small planets move faster. Yeah, okay, good. So small systems, like I said, some of these planets orbit every 7 hours. So if you're looking at a sun and gathering data and you see it blip every 7 hours, then you're like, oh, we've got a live one. Yeah. We've got a planet. I can see that planet and I can observe that in like a day. If alien astronomers were looking at our sun and waiting for our Earth to pass in front of it, they would have to wait 365 days.
They might get bored.
And then in 365 days, again, they would see it blip again. And in 365 days, they would see it blip again. And so you need to study it for a long time in order to see those planets. I guarantee you that there are solar systems out there that look very much like our own, with planets that orbit every 365 days or more. But those are much harder for us to see. So we need new missions to look at more stars for longer. We need to look at stars for 5 years. We need to look at stars for 10 years and gather that data, and we can find a lot more planets like that. This is a timeline of different things that have been searching for exoplanets. We had Hubble, launched in 1990. It's still up there. We had the Spitzer telescope that it wasn't exactly looking for exoplanets, but it was looking for other stuff, and it found some exoplanets, just kind of by accident. That's cool. Kepler is our boy Kepler. 2009 to 2018.
Great science.
It was specifically looking for exoplanets, and it found thousands of them. TESS, that's the name of this satellite. It launched 2 years ago, and it's operating right now. We're going to be seeing a lot of exoplanets coming from TESS.
Very cool.
In 2001 and in 2025, 2026, we're going to get more things launching.
And these graphics aren't to scale either, because
no,
the next one is just a huge telescope.
Yeah, this is the James Webb Space Telescope.
Nice name.
Isn't it the best name? It starts with the best letter. The James Webb Space Telescope. This is 100 times more powerful than Hubble.
Sheesh.
It's 100 times more powerful. Someone asked, how much longer are we staying on? We'll be wrapping up in the next 5 minutes. We're pretty close to the end. I'm just excited and I can't stop talking. So one of the most exciting upcoming missions to me is this one, the WFIRST mission. And WFIRST is not going to be looking for new exoplanets. It's going to be looking at existing exoplanets that we already know about. For example, it's going to be able to just look at the TRAPPIST-1 system. And its job is to do research on the planets in that system. Wow. Remember the spectroscopy we were talking about? Looking at the rainbows, the light that we can see from those other planets. That's what it's going to be doing.
Who's launching this one?
Humans.
Okay.
I forget if this is NASA or if this is the European Space Agency.
I'm not familiar with that one, but this is awesome. Wow.
Yeah. So like, hey, we know of at least 4,100 exoplanets right now. By the time 2025 rolls around, we'll probably know 4,000 more. This can look at the known exoplanets and learn more about those. How thick is its atmosphere? Is it as thick as Earth's atmosphere? More? Less? Let's find out. What's in the atmosphere? Does it have the right amount of oxygen? That telescope is going to be the one that tells us this planet is the same size as Earth. It's got the same gravity. It's got the same density of atmosphere, and it's got the same stuff in the atmosphere as Earth. We could literally land on that planet, walk out of our spaceship without a helmet. That's going to be amazing.
Cool.
Probably 2030 is when we're going to be getting that information. Right around the corner, guys. Just wait 10 years. Just wait 10 years.
Be at NASA.
Maybe some of you are going to be in college working on that project at that time.
Wow.
That would be so cool.
Shoot us an email. Let us know.
Please, let us know.
Your webinar from 2020.
Yeah.
I'd love to get an email like that.
That would be so cool. Awesome. Maybe you'll call it, Planet James or Planet Diego. Or here, we found the bow tie system.
Planet Delphian.
Planet Delphian, yeah. Thank you, everyone, for staying with us long today. I knew I was going to go long. I knew it. Next week, we're going to be talking, I think, Thursday, Friday, or Wednesday, Thursday. We're going to have 2 more webinars. We're going to be talking about what are some things that, like devices and technology that we made for space that we now use every day.
Space spinoffs.
Space spinoffs. Yeah. Like, do you like DVDs? Do you like Blu-ray? You can thank the space program for that. We'll learn more about that on Wednesday. On Thursday, we're going to be taking a closer look at every planet in our solar system and some of the moons in our solar system to see what makes them interesting and unique and what secrets are they hiding? What mysteries do we still want to uncover?
So much to learn. Even our bottoms of our oceans, we still haven't seen. There's so much to discover all around us.
So thank you so much for joining this webinar and everything so far this week. Have a great weekend. I can speak. Have a great weekend, and we'll see you next week.
See you guys.